Okay, looking further at non-parametric tests, we're moving on to the Wilcoxon signed rank test in this video. The one thing I should say, first of all, it's quite important, is that we do assume that the distribution is symmetrical, otherwise this thing won't work. It's not always true. Some people say that there's no assumptions about the parent distribution for a non-parametric test. Sometimes there are assumptions made, but they are not particularly restrictive, and there's certainly nothing to do with the normal distribution. So that would in itself make it non-parametric. Okay, but there is here the assumption that is symmetrical. Like the signed test, t-test, the signed test, this test for the median of a distribution. So wherever you could use a signed test, well, no, that's not quite true. Of course, signed test doesn't require symmetry, whereas the Wilcoxon one does. So you could always use a signed test for a Wilcoxon signed rank test, but not the other way around. However, because the test takes account of far away each individual observation is away from the median, the test is more powerful than the signed test. It is more likely to correctly reject the null hypothesis, i.e. to reject it when it should be rejected. This is for those of us doing OCRA, there's not really you're not required to understand the detailed kind of definition of type 1 and type 2 errors. The type 1 error, though, is where you incorrectly reject the null hypothesis, and whereas a type 2 error is where it's the other way around, basically, where you should reject the null hypothesis but you don't. Type 2 error, or sometimes called in more colloquially a false negative. Okay, so but that's not on, it is on other A-level courses, AQA, one of the EdXL ones definitely, but it's not on the OCR course to understand about powers of tests. Not in detail anyway, but I think you should at least know that this is a more powerful test. So if you know that a distribution is symmetrical, then you're better off using this test than the signed test, because it's more likely to tell us something. So let's do an example, same example as we did last time with the signed test. So it's all about the median, so let's write up our null hypothesis. H0 is that the median is 150. And H1 is that it's not 150 because there's no indication of a direction that we suspect here, so it's two-tailed, which is what we will test whether the median mass is 150, so or not. So the or not is kind of implied. It certainly doesn't talk about an increase or decrease, so we need to go for a two-tailed test. Firstly, it seems a little bit unintuitive the way this test works. Thankfully, I'll just pull this down. The actual this here is given in the formula book. The kind of process is given some kind of guidance in the formula book for OCRA, and you're given table of values which work for small samples. So I'll just take you through one example here, and then we'll hopefully you really got the idea, and that should be enough. So the first thing we do, because this test takes into account how far something is from the median, is just look at the difference between the median under our null hypothesis and that particular data value, taking care of the sign, being aware of the sign. So we've got -3 there, -12 there, and so on, if I fill the rest in. And we rank the magnitudes. Okay, so it's the magnitudes that matter here. So whether it's negative or positive we ignore. In other words, it's how big it is, so we take out the negative. So the smallest magnitude is the 152, which has a difference of only 1. Oh, sorry, which has a difference of only 2. So that's the smallest, which is 1. The next smallest is the 147, which has got a difference of 3. So that's the next smallest. And then the next smallest magnitude is the -5, because it's a magnitude of 5, which is next smallest, 3. The next smallest is the -7, so it's 4, and so on. The -8 is 9, 5 of course, and then the next smallest magnitude is the -9, which is 6, and then the 12 is the next smallest magnitude, which is 7, and the 21 gives us 8. It's the size. I think I said negative is the smallest magnitude. It doesn't make sense. It's the we just modulate the numbers. Some people add in a row, but it shouldn't be necessary. I've made a bit of a jumble with my words there, but it shouldn't be too difficult to arrange them in order of magnitudes, smallest first. Right, so then we just need to actually almost consider the sign again. This is the thing called the signed rank. It's important we know what signed rank means. And basically it's this is the actual modulated rank, but what we do is we take into account whether the difference was negative or positive originally. So here we had rank 2, but the difference was negative, so it's -3. Here we had rank 7, but the difference is negative, so it's -7. Here we had rank 8, the difference was positive, so it's +8, and so on. It's this row of signed ranks that's the important one for getting our... This is the one where we get our values for W plus and W minus, and then get our test statistic T from. So this is the row that we need to look at. W plus is just the sum of the positive ranks. So W1 is 8 plus 1, which is 9. So W plus is 8 plus 1, which is 9. And then W minus is the sum of the negative ranks modulated. So that's -3, -7, -5, -3, -6, -4. Which is 27. Now, statisticians have different approaches from this point. Some people consider the difference of these two, and some people look at the smallest. The actual can be shown the test is statistically equivalent, whatever you do, but it's simpler to take the smallest, I think, and in any case, that's the guidance at OCRA. For those of most people watching this video are probably doing OCRA. We take the smallest of those. So T is the smallest of W plus and W minus, which is equal to 9. So we just then refer to our given table of values in the formula book to see whether we've got enough evidence there to reject H0 or not. Remember, it's two-tailed test, and the significance level is 5%, and the sample size is 8, because we've got 8 data values. So let's have a look. We need 8 data values. Okay. And it's a two-tailed test at 5%, so our critical value is 3. Equals 3. But our T value, which is 9, is greater than the critical value, which is 3. So this is where it's a little bit unintuitive, and most tests, I think, your intuition knows whether to reject H0 or not. This one's a little bit less so, but mercifully it is told in if we go back to the actual formula guidance, it says the largest value, the critical values are the largest value T, which will lead to rejection of the null hypothesis. So it's the largest value of t that will lead to rejection. So 3 is the largest that it could be for us to reject the null hypothesis. So we'd reject the null hypothesis if we had 2, 1 or 0, but we've got 9. So we do not reject H0. And then we need a contextual statement, something like there is insufficient evidence to suggest that the median is not 150. Sorry, the median is not 150. Okay, so that concludes the thing. You just follow the process, and it's like turning a handle, really, a little bit. I say it feels a little bit odd, but thankfully there is guidance given in the formula book if you're doing OCRA. Right, so we will return to this in a later video, because what the process of using these tables here really works for small samples, and we'll be coming back to this again for larger samples where we can actually approximate it to the normal distribution, but that will come in a later video. So that's it for now. Hope that was useful. Thanks. Bye.